Hello guys, in today's episode. Today I want to talk about stroboscopic lamp. It is a very good point to build an interesting project with it, because to make it we need high power light source and we need to switch it on and off very quickly. So let's get to the practical examples and stop talking. So now let's talk about the advantages of MOSFET and relay. So in our project we'll use mainly relay because of its fast response time. It can switch on and off 1,000 times a second. But MOSFETs are delicate. You need to protect them against high voltage spikes. Some MOSFETs, the MOSFET that I have used, which is IRF 520, it has internal flyback diode, so it is protected, but not all the MOSFETs have those features. So you need to remember that you need to protect MOSFET against high voltage. The MOSFET makes very big amount of heat. The relay doesn't. Of course, sometimes if you will connect too high voltage to the internal coil, it will start to heat up, but mainly it doesn't generate much heat. The MOSFET doesn't create sparks, and of course the MOSFET is semiconductor element, so it will not conduct AC. If you want to conduct AC, you need to use, for example, a relay or track. The AC is of course usable with AC, but it generates back EMF, so if you want to switch on and off the relay, and you need to remember that you need to add the flyback diode. In this case, I have showed you the relay module, and the relay module has built in all of those features. The relay can conduct high current, but for example, up to 10 amps, for example, with this module that I am showing you. But the MOSFETs can be powerful too. For example, 4 amps, 5 amps, there are some 10 amp MOSFETs. It makes sparks, so it can interfere with your electronics around. It is very, very slow. When you want to switch it on and off 1,000 times a second, it can weld. For example, the contacts, if you are delivering enough power, for example, and you want to switch DC, high DC with relay, the contacts of the relay can weld. So mainly the biggest advantage of using MOSFET is that it is fast, and this is what we will take advantage of in this project. So now I will show you the whole practical example. The setup is a bit messy, but I think I have explained it pretty nicely.
Okay, so now when we know what the stroboscopic effect is, let me show you my practical example of the stroboscope lamp or light, or as you wish to call it. Here we have the simplified schematic. So we got the main power supply, which is this thing. It is set to 12 volts, as you can see, and it outputs the power to to the constant current module, to the square wave generator. Both of these are connected to the MOSFET module, and then it turns on and off power LED. So where we have square wave generator, here's the square wave generator. There is a little mess around here. So here we have the square wave generator. The schematic of it is this. If you want to see a bit more about this, you need to go to my website on the what stuff I use tab, stuff that I use. So this is the square wave generator. Here's the current limit converter made on the LM317 IC. Then there is a bit mess because I am connecting the shunt to monitor the current that is going to my LED to not burn it. Here we have the MOSFET module. When I will remove the scope, you will see it a bit better. Here is the MOSFET, 2 resistors, LED input output. Pretty simple. Let's connect the scope again, like that. Here we have this power LED. This is how it looks like. simple power LED module. So let's get to the bit more advanced schematic. This is a bit more advanced schematic. Here we have the constant current converter built on the LM317. Here we have the power LED, here we have the MOSFET module, and here we have the square wave generator. So the square wave generator goes into the gate of the MOSFET transistor. Of course, to lower the voltage a bit, we connect 1 kilo ohm resistor here, and to monitor if we have connected some kind of signal, here we have the LED. So to lower this signal onto the gate, here we have the gate of this transistor. This transistor has built-in flyback diode from the drain to the source. So that's pretty much it, and when we supply it in here, it switches on and off our LED. I have made a little constant current source, mainly because too much current will just blow up my small LED, which we obviously don't want to do. So that's mainly this whole setup. Oh, sorry, a bit of the problems as always. So let's turn on the whole setup. Here we have the stroboscope. As you can see, it starts to interfere with my little camera. Everything is connected. Here we have the current that is mainly drawn by the LED, but the better way to show it to you will be when I will turn it to. Now the signal, as you can see on the scope, is mainly DC, so it just opens the MOSFET module and nothing happens. So this is the voltage drop across our shunt. 1 volt equals 1 amp across the shunt. So here we have 320 milliamps, which is nearly the maximum of this LED to handle. Of course, if I will get my screwdriver in a moment, I can lower this current. It can be lower, it dims the LED a bit, and the minimal current in this case is 140 milliamps. But the best, I think, amount of current to not blow up our LED is the recommended 320 milliamps. So that's why I'm limiting the current, because I don't want to burn the LED, and mainly that's the whole purpose. And the second purpose with this current limiting converter is that I will not heat up the MOSFET. So only the advantages, you may ask. No, because the LM317 constant current source is just heating up, the AC itself heats up. But besides that, we limit the current, and it is good in this case. So now, as you can see, it starts to blink. In person, it blinks much faster than on the camera. So that's pretty much the whole circuit. I am just limiting the current, fitting it into the MOSFET, which is switching on and off with a special frequency. Pretty normal thing. So of course I can measure. Another thing for you is mainly this constant current source. As you can see, this is our input voltage, which is 12 volts, and now I am measuring the voltage after the converter, and as you can see, it's 6.7. It holds mainly the current is mainly the same, but my meter will not show it because it is not DC current, because we are blinking this LED very fast, so it doesn't show it pretty accurately because the current is mainly the same. But let me show you this, why not? Let's just grab the different cable, because I don't want to disconnect this one from here. But mainly Now let's disconnect this cable, clamp on with the alligator clips to the shunt, like that, and then connect all of this to the scope, and then let's measure this. And besides the whole noise that happens in here, the volts peak to peak are mainly 0.3. Let's see how well we have calibrated the scope. Let's recalibrate it, and then yeah, 0.3 volts peak to peak. So the multimeter just doesn't show it here. So as you can see, this is the current that is drawn, and it is mainly the same as we have set it on a normal DC level. So of course when I am switching it, but then when it's constant, as you can see, the maximal current is still the same. So it's pretty useful to do it like that instead of just connecting the 12 volts straight to this LED. It will just burn. So this is just a bit more efficient way to drive at this LED. So let's connect our MOSFET module frequency, MOSFET module thing. You know, this is mainly this waveform. So now let's grab the fan, because the best way to show the stroboscopic effect is mainly with fan. So let's put the fan in here. Here I got the fan, here I have the cables for the fan, and as you can see it spins pretty fast. So the frequency that I remember was the best was mainly something like that, I think. The shortest possible time of the impulse and the highest possible frequency. And now when I will connect the whole thing, put it in the middle, grab something that will hold LED for me, and now I will zoom in, and zoom in. And now with a bit of jiggling with the frequency, you can see that the fan starts to look like, oh, now it was visible. Oh, now it is truly visible. It looks like it is, you know, spinning much slower, but it doesn't. And this is mainly for this fan, and for this configuration this is the waveform. The measurements, you know, my scope is not capable of measuring it, but mainly it is somewhere around 60 Hertz, and the measurements are not pretty stable, so that's pretty much the whole waveform. And the current, let's measure the current that is drawn by this configuration. Okay, camera is positioned. Okay, so the current, of course I will be measuring only the current that is drawn by the LED, not the fan, because there is no point of measuring the current drawn by the fan. So the voltage in this exact configuration, this exact frequency that is supplied to the LED is roughly 11.3 volts, and the current that is drawn is very small. My multimeter is not capable of measuring it, I think. Yeah, my multimeter is not measuring it. accurately enough. So that's pretty much it. That's the very good solution to make yourself a stroboscopic light for stroboscopic experiments. I will, make this setup a bit less messy, so you will be able to see how the whole thing looks like when connected. Let's disconnect the LED for a moment. Here I have the shunt that I was using for measuring current. Let's get rid of it. Let's get rid of it, and here we will connect the LED itself. I will grab the screwdriver again. Here's my screwdriver. I will screw down the terminal for that. I will make the LED a bit more bright, and this is mainly the whole setup. I hope it is a bit more clear now. So let's just leave it as it is, like that. So mainly here we have the main power supply, then it goes to this very hot current limiter circuit based on the LM317. Here we have just on the input, ouch, this LED is hot. Here we have the LED connected on the input. I hope you can see it better. Now I think it is better. LED on the input, capacitor, resistor, potentiometer, and capacitor on the output, and then it outputs the voltage. And now, as you can see, voltage is 4.3 and the current is limited to roughly 300 milliamps. So then this current limited voltage goes into the MOSFET module. In the MOSFET module we connect our load, which is our LED, this little guy, and then little LEDs for indication and the square wave generator. And that's pretty much all the stuff that I can tell you about this stroboscope. Of course you can replace this LED with a normal 12 volt LED that has internal color and telemeter, and it will be a bit more, the setup will be a bit more simple, but besides that, that's what I wanted to show you in this episode. I hope it was somehow interesting for you and you will build something like that for yourself. So see you in the next episode, and thanks for watching.
It would be nice if after watching you can press subscription button and hit the bell icon.